What I would like to talk about today is an attempt at using Twitter data and digital breadcrumbs data to track population change and explore dimensions related to demographic analysis and demographic change. This is a co-author work with Eric Chan at the Federal Reserve Bank in New York, Ingmar Weber from the Qatar Computing Research Institute, and Francesco Billiari, who's at Bocconi. And the background, in a way, is the fact that we are, we're very aware of this, so I'm not going to spend too much time. We are witnessing a data revolution, like every day online, massive amount of data is created, and this huge data generating process actually puts demography not in a bad spot, because demography, in a way, is and always has been a data-intensive science, and data innovation and data collection innovation are actually have been at the foundation of the development of demography, like from Marcus, Grant, and Harry. And the idea is that, demography knows very well big data. Now, the point is how to use new big data to have new kind of ways of analyzing population change. And what can we gain from this data? Because we know there are a few shortfalls of using this data. For example, there's a problem of bias and of representativeness of the data. Agnese has been working on this. So the idea of these are non-random samples. These are very self-selected groups. So how can we actually say something about ground truth of population change using this data? It's a very important question. And there are techniques, and we are going to, of course, address this point. The point of the paper that I want to present today is that still, despite the fact that these data are non-representative, they still can say something. We can still track something that is going on in the population by using this data, and especially Twitter data. Another issue that, just to give a very broad introduction of the issues we face with digital breadcrumbs with digital data, is that these data are generated by typical private companies in a decentralized way, and they are actually, in a way, a byproduct of the interaction that users have on the website. And companies now know that these data are actually very valuable, and they are based, their business model is increasingly based on these data. And what we have been observing is actually in a way, diminishing chances for researchers to access this data. So historically, you would have an API, an interface for to talk, in a sense, to the websites and get data out of them. But since 2011 up to today, Twitter and Facebook and Instagram have been closing down the possibility for researchers to and restricting the possibility for researchers to access this data, so that this is going to be, very important, a very important issue for researchers in the digital age. Data accessibility, and more so, data are accessed through protocols which are, based on individual cases or individual projects, and then companies can actually ask you to have specific research questions. For example, Facebook is now opening up data, but for specific research questions. So it's very difficult for researchers to be in control of these data. Okay, Twitter though is relatively okay. Twitter now still it's public data. You can go and download them, and you can do a lot of things with Twitter data. So just to give you a few examples. So first of all, you can try to derive some population structure. The way people have been doing this is to take the pictures that users upload of themselves in their bio, and run the pictures, as in Agnese's paper, on some services, for example, Face++, or even Microsoft And these algorithms can try to recognize age or estimate age, ethnicity, and gender of the person, of course, of the people who actually have pictures of themselves in the bio. And these algorithms are getting better and better. I mean, they have some problems. It's not difficult. It's not easy to find, to actually estimate the age of somebody from their picture. But there are a few attempts of doing that and deriving these population structures as well, using names. Like, since more and more people have a reason to be online, which is related to self-branding or like identity and authenticity. A lot of people just use their real names, and from real names you can use dictionaries to infer gender or ethnicity, and in some cases even or in some countries even as proxies of socioeconomic status. Another thing that can be possible, that is possible to do with Twitter data, is deriving population movements. And some of the tweets are subset of the tweets are geotagged, so we know where people actually tweet from. And this is a paper by Zaghini and co-author. Basically, there's estimated out-migration rates based on, we can observe somebody tweeting from one country, and then the next year this person is tweeting, or in this case, as you can see, like in the next 6 months, is tweeting from another country. So, and in this paper, it's a very nice paper where they try to see whether these track real population movements from the data we have, which are typically incomplete and very difficult to reconstruct, and then indeed they do find that there's a tracking. Of course, this can also be done within countries. For example, commuting patterns are are potentially it's possible to study them with Twitter, because if many people tweet multiple times per day, so I can tweet when I'm home and then while I'm at work, and then when I tweet when I go back home, and so we can basically track movements, especially in large urban areas, or like across states in the US or in some parts of Europe. We can also have going a bit into more details, like estimations of population characteristics. In this paper, one of our co-author, Ingmar Weber, uses, as you can see, mentions of food and of other, food names, and they use these mentions of food names to estimate kind of like in a way, the caloric content of the consumption of population, and then try to predict the country-wise obesity and diabetes statistics. So the idea that you have a lot of information buried in the tweets, and you can try to look at group characteristics. This is another paper trying to predict the emergence of depression and post-traumatic stress disorder in Twitter users, looking at again 279,000 tweets, and so basically on the one thing that can be done, you look at the sentiment or the emotional content of the tweet, and then you can see how that changes. And this is also based on some dictionary. Finally, you can use tweet hashtags to see how things spread. And this is going to be a key concept for our paper, because although we don't want to just simply look how particular hashtags spread in 1 week or 2 weeks across the population, but we want to see how ideas spread in different populations, and we are going to use Twitter data to look at the US case and to look at how culture-based family change can be tracked based on specific keywords. This is exactly what we want to do. We use Twitter to estimate how prevalent are specific cultural attitudes related to life course transition, in particular family formation and childbearing, and also ideally lay the foundation to use this method to track change over time. Of course, the background, the theoretical background we work on is the idea of second demographic transition and the decline of traditional gender segregated family roles, and the emergence of kind of like more modern ideas related to family. This is the Google Ngram, so this is again big data but based on books, digitalized books, and this is the frequency from the 1800 to 2008 of the word mother and wife and partner. Again, you can see they kind of like move together, and then around the 1970s there is this decoupling of the frequency of the use of these words, while wife kind of declines, the use of word mother like increases. This for us is like a very simple way to look at how family changes, kind of like how family ideas kind of decouple from traditional monogamic heterosexual couple and become more complex, or basically parenthood becomes the real in a way signal for family formation. And the reason why I'm showing you this is that we are going to use exactly this word. Like, we want to go on Twitter and look how many people define themselves as mother or fathers relative to people define themselves as husband or wife, so like more traditional heteros. I'm going to look into that in a bit more detail, but the sociological reason why we're looking to like how people describe themselves is, goes back to Goffman and the presentation of self in everyday life. The idea that people have self-identities and they bring their identities in a social space, in day-to-day interaction, and now we basically, in a way, there's another layer of social interaction, which is the digital space, and even in this space there is the problem of presenting yourself. And people express, their identity on Twitter. This is Ingmar Weber, again one of our co-authors, having, like his newborn Sophie, and people just share this on Twitter, and we want to try to tap into that. We want to try to tap into this idea of using social media to portray identities and then try to infer, like population level dimensions from these micro kind of level data which are offered and created by individual users spontaneously in a way. So in order to do that, we use a website called Triangulate, which basically allows us to explore the Twitter user space, so crawl through the users who use Twitter. It's 300 million active users on the platform, and by using Boolean operators, we implement queries on the Twitter user bio. So I don't know how many of you have Twitter, probably a good portion, and Twitter asks you, we're going to look into that, to define yourself. And you may think about what you wrote and how you decided to word the short bio. This is basically the taxonomy of your identity. You've decided to exclude something, you have decided to put something in your bio, you want to be professional, you wrote about your job, you want to be more personal, you wrote about your personality, but this our idea is that it's telling us something about you. And we want to look into that. Again, we are interested in, since we are demographers, we want to be interested in family and family chain, so we use the word mother, father, wife, and husband, and kind of related colloquials like mom or dad. And we scrape kind of like these users by location. So I'm going to show you just a few maps of how the relative frequency of these words actually are spread in the US geography. This is simply the code, so as you can see, we look for the states, and there, because you can also write where you are in Twitter, and the code for the state, and then we just use wife, husband, mother. So it's very simple, very easy kind of like thing to do. And what the code does, it goes through here, goes through your bio. Barack Obama is in our sample because he defines himself as dad and husband, so he goes into both the dad and husband category, and Washington, D.C. So we locate the user in the state of Washington, D.C. So we get a data set like this, so we keyword and the state, and then we get description, so the bio, and then we get the full name, ID, so a bunch of other information, the location, and the number of followers and people followed by the user. Of course, there's also some false positives which emerge, and people that you don't really necessarily want in your data set, as this guy. So we have to do some filtering of the data. So we first start from 5.4 million hits in our scraping. So of course we clean by location, because a lot of people, for example, say in their location, I'm in my dreams, and in is the code for Indiana. So this person is not, for us, it's in Indiana, but it's actually they're in their dreams. So we want to actually put them out. And then we have also individual description. A lot of people will describe themselves as, for example, proud father of two wonderful Yorkshires. And so you also don't want people who are, describing themselves as fathers of dogs or other kind of pets. So you also have to do that. And this requires a bit of qualitative knowledge of your data. So in a way, using these data, since they're very noisy, it requires the researcher to have a bit of more qualitative understanding of the data compared to simply running a blind regression on data that you know are clean and come from a very representative survey, etc. Our final data set is like 2.5 million observations, so we do it over many months, and these are some descriptive statistics. So we have 2.5 million, and we can see that, for example, the number of, if you compare, for example, mom and dad, we have 200,000 dads and 700,000 mothers. So we can see that there is an unbalancedness by gender in the frequency of people, like women describe themselves as mothers relative to men that describe themselves as fathers, which is something that one could expect in a way, because culture change is a very slow process, and so we're still in the process. So so what we do next, we simply try to look at prevalences. So of course, father and husband will be correlated, because a lot of in the traditional transition you first marry and then have a kid. But as out of whether of childbearing and other forms of family emerge, we basically expect to have relatively more father and two husbands as a function of these emerging new forms. And when we plot this kind of like modern identity measure over traditional, we can see that kind of looks like something we know. I mean, it's like we see that in the coasts there are like more what we identify as more modern identities compared to the middle America and the South, and so we think, okay, does this explain something that actually goes on in the real world? To test this, we go back to a paper by the Stage, where he uses a bunch of measures, 13 variables from census data and American Community Survey to have principal components of the second demographic transition. And we try to see if our measures, very, very simple, very in a way efficient, kind of like correlates to the second demographic transition principal component, which are estimated by Ron Lestage. So this is the idea of, do our data tell something about the real world? And you can see, there's a nice, positive gradient. So when states in the US score low in the second demographic transition measure or principal component estimated by Lestage, which is given by the principal component of all of these variables, they score low in our measure of prevalence of modern family identities. When they score high in the principal component, we also observe more parents relative to husband or wives. And we were kind of happy about it in a way, right? Because we were kind of reassured by the idea of, yes, we do see the gradient that we expect. We see New York, Massachusetts, New Jersey, Rhode Island, and here we have Arkansas, Alabama. So countries, states, sorry, which we know are kind of like lagging from real data, let's say, ground truth data in the second demographic transition indicator. The next step, though, is to consider that, well, Twitter data are not only one word. I mean, mother, father, husband, and wives goes in a kind of like larger bio. And in these larger bios, there are this kind of cultural, what we call cultural correlates. So what are the words which appear together with mother and father? And do this change across states and as a function of the second demographic transition? I'll give you an example. These are two of the users which we identify, and on the one hand we have Tim Flowers from Alabama, Christ follower, husband, worship leader, and musician. So in a way, a picture with the kids, what we could define as a kind of traditional based on the traditional family identity, religiosity, and in a way, yes, traditional family. Well, here we have more Joanna Scott, we have a mommy blogger, we have some accent on work, researcher, and advocacy. So in a way, these appear as a more like diverse and modern kind of like identity. But still, the mother part is still an integral part of the way the user represent herself in this case. So now we want to operationalize cultural change, and what we do is simply run a frequency analysis, which is just not really fancy, but like word clouds, for the state which is the lowest scoring in the second demographic transition, Mississippi, and the highest scoring, Massachusetts. And you can see that these are the terms, the most frequent term, which appear with mother in this case, and you can see wife is of course prevalent, although by the sheer how big it is or largeness, you can see that kind of like it's a bit smaller, so it's less, as we know, it's less frequent to have both a person describing themselves as both mother and wife. We have a lot of religious terms in Mississippi, like Christian, God, which can tend to disappear in Massachusetts, but where we have emergence of something like more like related to the writer and like other jobs. We can hear marketing. So in a way, we can see that women who describe themselves as mothers also tend to have, like director, student, tend to have more kind of like identities which we would consider more like modern, more like not so traditional, and not, for example, you can see here in Mississippi we have married, wife, love, Christian, so like kind of traditional identities. Of course, these can just be state fixed effects, and what we want to do and what we are doing is then creating a panel where basically you can take care of this. It's very, very simple. So now, since we are quantitative researcher, we don't just want to look at word clouds and have some kind of like nice story. We want to run this in a model, and in order to do so, what we do is basically operationalizing these variables, these words as dummies. Okay, so we want to, for example, take all the terms related to religion, Christian, God, what else? Churchgoer, etc., and then we create a dummy for users where these terms appear, and we say, okay, these users are religious. And when we regress, these on the second demographic transition indicator, we can see that there's a weakening probability of observing a mother who defines herself as religious person, or like who have religious terms, as a function of the second demographic transition indicator, something that we would expect. As you can see, it's quite like monotonic decrease. We can then experiment with, whatever. We focus, for example, on type of work. So for example, we have a dummy one for for mothers who also describe themselves as engineers, scientists, or other like STEM-related jobs and activities. And you can see, okay, there's actually these increases in the probability of observing mother who also work in a STEM related occupation, like increases in the function of the second demographic transition. I mean, I'm presenting this for mothers. We have a bit of like more observations, but of course you can with fathers it looks exactly the same. And when we put everything together, for example, so we looked at religiosity, jobs, but then we also try to look at something, for example, like feminism, and how many mothers or fathers describe themselves as feminists. And we can see here there is an increase in the probability of observing parents who describe themselves as feminists as a function of the second demographic transition. By the way, you can see the probability is very low. It's here is close to zero at the low stages of second demographic transition. Of course, this is the condition to the fact that our data set doesn't have non-parents. However, now we have a better data set. We just finished scheduling, so we also have non-parents. So I guess if we run this model for the whole population of Twitter users, we would also expect probably to have a kind of better understanding of the probability of observing parents who are feminists or whatever category correlate as a function of kind of like the sample, the population and the second demographic transition. So what are the mechanisms here, just to conclude? Go back to Espinal and Billiari. So the idea is that we think about this as a way to track cultural change, and we know that family demographics is shaped in the second demographic transition framework by ideas and by the spread of ideas. And what we want to look at is maybe also to use Twitter data to track that and to see and to try to understand whether we can say something about diffusion. And on this, we are just starting to work on this, but one idea was the role of networks. So do, for example, people cluster, so like mothers or fathers are more are clustered so that ideas spread in the network. Do they have more or less followers at low versus high second demographic transition regimes? The idea being, okay, if you're in like a traditional identity in those second demographic transition environment, you might have more followers, so you might have more social support in a way, and the idea kind of like stays. Or relative to like a person with a traditional family identity in a high second demographic transition equilibrium, where basically it can be that you are like a marginal or marginalized identity, where basically it is less likely that you have strong networks and cultural diffusion, and people can sort of pick up kind of behaviors. But this is a more complex analysis, which we don't go. We will go into in the future, I hope, but not for now. It's just the point that I'll try to make with this presentation was that, what we claim is that web-based, this sort of breadcrumb data can be useful in analyzing this fast culture-based demographic change without imposing strong a priori theory. So we're not going to people and ask them, items from a survey. We just take the word as they appear in the real, take the data as they appear in the real world, and then we try to make sense of those. We use Twitter to track differences in the rolling of the second demographic transition in the US, and we find that Twitter-based measures, which are very easy, like simply the number of people who describe themselves as mother and father on the number of people who describe themselves as husbands or wives, correlate to a complex low-frequency measure, which is based on 13 different variables taken by the census of the US and the American Community Survey and other sources. And, they correlate in a kind of satisfactory way. And we didn't even go into the adjusting or weighting or it's a simple bivariate correlation. And then finally we propose a way to operationalize and assess cultural change via quantitative text analysis of the bias and of the cultural correlates that we observe emerging from different second demographic transition regimes, and we show that the rolling of the second demographic transition correlates to different concepts of parenthood. Okay, what we're going to do next is this is US, and it's easy because it's English, and it can be done, of course, for the UK as well. We would like to have more of a global idea of research project, because there's a lot of parts in the world where there's a lot of stuff happening and very fast. Like if you think about the transition to Latin America, cohabitation in Latin America in the last 30 years, which was very fast. And since these are culture-based, we think they're culture-based changes, data from which are created every day from Twitter can be a very potentially a very useful resource to actually track this change. And of course, there is a lot of work to do, and I really urge you, to think about it, to do in terms of using these texts, these works to create subpopulation, track subpopulation, understanding how they change in time, and this can be done. Point being, with a very computationally efficient and in a way easy method, which is simply looking at how people go online and talk about themselves. Okay, that's it. Thank you.